Okay, as we look at 6.3 and 6.4, what you'll want to do is you'll want to get a hold of the truth table cheat sheet that is found in D2L, and that is found on 6.3 and 6.4, called the truth table cheat sheet. And on here what it does is it tells you the assigned letters for a proposition. And if you have two letters, A would always be true, true, false, false, and B would always be true, false, true, false, true, false, true, false, right? If you have three letters, A is always true, 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 and then four false. B would be true, two false, two true, two false, and C is true, false, true, false, true, false. And then if you have four letters, obviously, you have 8 trues, 8 false. You have 4 trues, 4 false, 4 trues, 4 false. You have 2 trues, 2 false, 2 trues, 2 false, and then every other true and false. At the bottom of the cheat sheet, and this can be used on the test as well, you're going to find the rules. And a conjunction is true if connecting two true statements, otherwise it's false. What we went through in the slides of the last section. So these are just repeated, but it's right here on an easy form for you. Most of everything that we're going to do, some of your homework applies to this one. Have fun with that. But on the test, we will try to keep things down to a minimum of 3 or 2 letters within every proposition. So hopefully that will help you out. So let's look at a PowerPoint. And this is on truth tables, and this is kind of a fun one that somebody found one time, put together by Austin Powers Group, so we're going to use it. So a truth table makes making truth tables is simple once you follow the easy steps. Determine the number of different propositions or letters that you have in your statement. Letters preceded by the tilde is still the same letter, and the number of lines is determined by the number of different letters, and that's mathematical, and you'll find the same thing if you deal with truth tables in some of your math classes. Each letter must be given the same pattern for all uses, and even if they are in different statements. So no matter where an A appears, it would always be true, true, false, false. Okay? Or true, 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 false, 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 false. Okay, so keep that in mind. The patterns on the slides will show you how it goes, and so once again, this is what we just showed you on the truth tables. Okay, so start with the tilde that's directly next to the letter, then perform the functions inside the parentheses, and we talked about this last class, so it's a review. And so once again, the rules. Okay, tilde changes it to the opposite. Conjunction is true if connecting two true statements, otherwise it's false. Disjunction is false if connecting two false statements, otherwise it's true. Horseshoe is false if the statement to the left is true and the statement to the right is false, otherwise it's true. And then we have biconditional. If both are true or both false, it's true, otherwise it's false. Okay, so same rules, and we just show them in different places. Okay, using the truth table for one statement. Okay, if the circled line is all true, then it's tautologous. If the circled line is all false, and the circled line being your final answer, it's self-contradictory. And if the circled line has some T and some F, it is contingent. Okay, for two statements, we deal with greater things. So instead of tautologous, which is logically true, self-contradictory, which is logically false, or contingent, now we're going to talk about logically equivalent, contradictory, consistent, and inconsistent. And if we go to our textbook, I have a textbook here somewhere. If I go to page 338, you will find at the bottom of page 338 this little graph. If we go to page 339, at the bottom of page 339, you'll find this little graph. These two little graphs will become very, very important to you because they tell you, okay, if I have more than one statement, okay, when I go all the way through it, if I have the same truth value on each line, then it's equivalent. If I have opposite, it's contradictory. Right, and so it'll go through, and we'll give you some examples, and we'll talk about it in class and see where it goes from there. I will be having another slide, another video that goes with this, where I actually work a truth table out on an Excel spreadsheet, and we'll work through it step by step. So make sure you watch that, and that will help you out. Okay, so If you only compare the circled lines for each statement, when you're using it for arguments, if there's a row in which all of the premises are true and the conclusion is false, it is invalid, otherwise it's valid. So let's do an example and let's see how it works.